learn about the keyword static in 5.7. Um, Static changes how things work so that you don't have an individual property, but more of a shared property. So we can make a variable static, and if we do that, we're making it so that the entire class of objects would share in these features. When you think about the AHS student class we've been working with, students have like their own individual names, their own ID number. One student could be in ninth grade while another student could be in 10th grade or 11th grade. And there's a lot more individual features we could have. You could have a home address, a home phone number, all kinds of things. A class variable or a static variable is a shared attribute. So these are things that you wouldn't really have individually. All AHS students would share. All students at Arcadia High School, like if you're applying to college or something, you list the same school address at 180 Campus Drive. There's one principal for all Arcadia High School students. Arcadia High School hired a new principal. It wouldn't make sense to go into each individual student and change the name of the principal. If we had a static variable, then we could make a change to it once, and all of the students we had ever created, past, future, whatever, would now actually have the update made. Um, at school, they serve the same lunch to everybody. Okay, so you don't have individualized lunch options. Every student at Arcadia High School can get the same lunch on a daily basis. So these are some variables I just thought of for making up the static examples. And I've changed a few things around in the constructor. Now, we can make a method static. And when we do, we've seen previously how you can call the method differently, and it might make a little more sense now. You would call it through the class name because it's not an individual property here. So we're not talking about something individual at this point. We're talking about something collective. If I set the lunch special, I'm changing the lunch option for every single student created ever. Okay. And if I get the lunch special, it's again the same for everybody. Um, Same thing if I were to change like the address to the school, I would do that through static variable school address. Now, if I wanted to set your home address, notice that I didn't put the word static here. Students have their own home address. You live somewhere, your friends live somewhere else. Okay, so that's an individual property. When you make a method static, you can only use other static stuff inside of it. So in terms of method calls, in terms of variables, you can only use static variables inside of here. And that makes sense because it wouldn't make sense that you could call a method on a group of objects and make individual accesses or changes to it. Now, you can use any type of variable in non-static methods. So for example, like if you look at my toString method, this is a non-static method, yet I'm still able to use things like school address and principal name here. Because even though it's a group property, individuals still possess that property. The difference is like if you're talking about a group-based method, like set school address, you tried to change somebody's home address through here, that wouldn't really make sense because remember this method is supposed to apply to the entire group. So like let's check out a couple things here in the main method then. And I definitely recommend reading through the notes, okay? But here I've got a couple of students that I've created, right? Three of them. And if I call the toString on them, we'll see like their three prints right here. And in fact, let me go ahead and turn off this bottom portion. We'll try that later. So just take a look at these first three students. And for Ryan Evans, I went ahead and gave him a personalized address. Now, all three students have the same uh, address for the school, right? 180 Campus Drive. They all have the same principal. Right now, only Ryan has an address listed because I only built his student constructor. Now, in my HS student class, I have a set school address method. I also have a set home address method. let's try both of those methods out here. Okay. Um, that's really any of the students. Let's say we go into S1 and let's go ahead and set one's home address. Okay. To I don't know, so like 123 Main Street. Right. Now that's only going to change in student one. We'll see that the next time we print it right here where it says null for Sharp A. It won't change Chad, it won't change Ryan because everybody has their own address. However, I could go into the AHS student class and I could set the school address. Um, And if I call this, notice that I'm calling it on the class of objects, not an individual. So all students at AHS are going to receive the change. And, we could keep it at 180 Campus Drive and at Arcadia, or let's just put like Arcadia, CA. So instead of just writing a street address for Arcadia, California, what you're going to notice is all three of these students are going to change their school address, but only Sharpay is going to change their home address. So let's see the effect of this here. Now, non-static methods, right, need to be called on objects. So anytime you want to call a non-static method from a class, you have to call it on an object reference from that class. Okay? And you're given access to all of the instance variables within that object. You're also given access, and we'll try this in a minute, to the static variables and methods as well. You're calling a static method, you really should call it on the class name. That's unless you're in the same class, then you can just call it, with no prefix. But here, I really should call it on the class name. Notice how all three students changed their school address. Okay? Only Sharp A changed her home address. That's what we were expecting. The same thing would happen if we changed the principal name or something else there. Okay. You can actually call this on an individual object and it would actually have the same effect. It's weird. Like this, it would change all three students' school addresses, even though I called it on S1. This is not like the recommended way to do it. You can do it, but it's preferred definitely to call it on class because even though I called it on the individual object, it's still applied to the entire class. Like I can't change that behavior of it. So it's a little misleading to call it on like a particular object. So even though you can do it, it's not really recommended. I'll set this back to Arcadia, California. And then if we came over here and we wanted to try out some of these other, examples, we could. So like, for example, I had that lunch special. If I set the lunch special, I can do that and apply it to the entire class of objects. Another kind of weird thing about static methods applies to our main method is that these things exist like prior to any objects being made from the class. So like notice at this point in my code, I haven't even created an AHS student reference yet, and I could set the lunch special at this point. Okay. So I don't think you guys have Crispitos anymore. But when I started working at Arcadia, that was like the big thing. Everybody moved to Crispitos. And then I think they were deemed unhealthy or something. All right, but yeah, I could set the lunch special here, and then I could actually maybe print it down here. I could even print it right here, like prior to any students being created, since I'm calling it through the class anyway. I think I had a method in there which is called get lunch special, and let's see what that happens. It should print Speedo right on top of any of our student and yeah, so right here. Okay, so we can use static methods and even static variables prior to any objects being created from the class. And if we made any of these static variables public, I could do the same thing. Let's say I made this a public variable. and I could actually access it directly from anywhere outside of this class. So I could say AHS student principal name, and I could set it like right here, like what if I wrote Mr. Reisky. Now Mr. Reisky is going to be the principal for all three of these students. Okay, we'll see that change here for all three of them. And again, it's interesting to note that that variable exists, and you can access it before you've even created an object from the class. And it just, I wasn't doing that up here. Right? This is all just. So that actually goes to the main method. And by making the main method static, we can access it before we even made any type of reference to the main class. So you can actually write like a call main before anything has happened. Now, since this is static, that means that I can only call static methods and static instance fields within it. And so that can be a little bit tricky sometime if I had made some other variables that belong to this main class. Now, when I create an object here, this is then a local reference variable. That's why it doesn't have to come from something static. Like if I make any variables in here or access them here, they're local at that point. Um, so again, if we came over here and we tried to reference a variable that wasn't static, so for example, like the home address, I don't know why we would do that here, but for some reason, if I tried to say like home address equals and a quick string, it's going to reject that. You're not allowed to access anything non-static from a static context. Okay, so this is just going to give me an error message. All right. One kind of real common use of like a static is to create sort of like a uniform numbering system. So like a common question type thing that you might see a way to use static. So say that right now, if you remember, all of my ID numbers are showing up. It's just randomly generated. And if you did that, there's the potential that you run this enough times, two kids might actually get the same ID number, which isn't really what you would want. And at Arcadia Unified, like your ID number isn't really random. It's actually sequential, and that sequential numbering system had to start somewhere. So, for example, what we could do perhaps is we could set up the ID number as a static variable, and you can think of it as sometimes this is called like a seed or a starter. So I might write here something like private static int ID starter. Okay. And maybe I'll start it at 10,000. And now what I'll do is the first kid that gets an ID number is going to be 10,000. And then I'll increment it. And so the next kid would go from there. So right here, what I'm going to do is I'm actually going to put this ID starter. Okay. Then I'm going to increment ID starter. Now, what happens then is that ID number, okay, it's going to be initialized with 10,000 for the first kid. So that's going to be sharp. Okay. At the moment over here in the main method, when we call that constructor that led to the creation of sharp A, then 10,000 was put in for her ID number. That method call, that constructor call, right, it invoked this code segment. Not only did it initialize her ID number to 10,000, it actually then incremented ID starter, would go to 10,001. And that's a shared variable. So what's going to happen is the next time that we come into this constructor, this won't be 10,000 anymore. It'll be 10,001. Remember, this variable existed before we even called the constructor. So calling the constructor doesn't like reset it back to 10,000. It's in a pooled area of memory. So now the next student that we create, it's going to be Chad. He's going to be 10,001. Now, okay, Ryan's a little different because he came from a different constructor. So he's actually going to be set to 8888 because we put that in there a little differently. But what we'll see is these students down here are going to pick up. They're going to be 10,002, 3, 4, and 5. So let's see if that happens here. All right. So Sharpay got 10,000. Brad got 10,001. Now, like I mentioned, Ryan came from a different constructor. This didn't apply to him. If you look at these next four students, 10,002, 3, 4, and 5, they're coming off of that seeded ID number. Okay. So if I didn't make this static right here, then it would behave a little bit differently. Okay, what would happen is with the creation of every student, the ID starter would be set to an individual property of 10,000. So if I don't put the word static there, this is an individual property. Everybody starts at 10,000 and would get their ID number initialized to 10,000. ID starter would go up to 10,001, but it wouldn't really matter. That would just be like a second variable that each individual was holding on to at that point. It wouldn't be shared amongst them. And so everybody would have two ID numbers, basically, one called ID number and one called ID starter. So, like, watch what's going to happen right now. All of these kids are going to have ID numbers of 10,000 for the one. So let's see if this happens here. Okay. So yeah, you can see everybody came out at 10,000 except for Ryan because he went to the other constructor. But you can see that everyone else is at 10,000. It wasn't shared, it was individualized. If I put it back to static, and everybody's sharing that variable, and it exists before we even make an object from the class. Since it's not individual, then every time you increment it, it's actually a lasting change because everybody has access to that same one. There's only one variable now. So everybody's increment leads to the same place. Increment it from here, okay, for Sharpay, it also increments the one that Chad's going to access. And it also incremented the one that AA is going to access and BB and so on. They're all talking about the same variable. There's not like a bunch of different ones being made.